After years of anticipation and preparation, NASA has successfully transported the Space Launch System rocket and Orion capsule to the launch facility for comprehensive testing before the Artemis II mission planned for February. The journey marks a pivotal moment in America's return to deep space exploration. Meanwhile, lawmakers have approved substantial funding for NASA's initiatives, establishing priorities for the coming years. Simultaneously, the scientific community has voiced strong objections to terminating the Mars sample retrieval mission, emphasizing its importance for planetary research and national competitiveness. Following over 3 years of waiting, NASA's advanced lunar exploration hardware, consisting of the SLS rocket and Orion spacecraft, has begun moving toward the launch site. Transporting the fully assembled SLS and Orion system to Launch Complex 39B represents years of engineering work, validation testing, and system improvements. The transportation occurred at 7 in the morning Eastern Time on November 17th, timed deliberately to coincide with favorable morning weather conditions. This scheduling provided excellent illumination and clear visibility, enabling engineering teams, journalists, and space enthusiasts to document stunning imagery of this significant event. The enormous launch vehicle, which had been completely assembled inside the vehicle assembly building weeks prior, commenced its methodical journey using the legendary Crawler Transporter 2. This massive tracked platform transported the SLS and Orion configuration along a specially maintained path spanned roughly 4 miles or 6.4 kilometers from the assembly building to the launch platform at Kennedy Space Center. The entire transportation process consumed more than 8 hours, proceeding at an extremely measured and careful velocity. Initially, the slow speed might appear unnecessarily cautious. Nevertheless, there exist compelling justifications for this methodical strategy. The complete vehicle traveled in an upright position, reaching nearly 98 meters in height. This establishes the SLS and Orion combination as the tallest rocket system currently moved in vertical orientation. Although SpaceX's Starship possesses greater overall dimensions and height, it travels in components that are considerably shorter than the fully integrated SLS. Beyond its impressive height, the Artemis II launch vehicle possesses tremendous mass, introducing additional operational challenges. Given these considerations, NASA prioritizes absolute safety throughout the transportation operation. Any structural damage incurred during movement could compromise months or potentially years of development work, particularly for a mission already facing substantial public attention and scrutiny. Following successful transportation completion, attention transitioned to subsequent preparation activities. With the vehicle positioned at the launch site, NASA has roughly 3 weeks to execute numerous essential tests and final verifications ahead of the earliest potential launch opportunity. Currently, the earliest launch possibility for Artemis II stands at February 6th, providing teams with a constrained yet strategically planned timeframe to confirm all systems operate correctly. The initial critical checkpoint during this interval involves the cryogenic propellant loading test. Throughout this examination, liquid oxygen and liquid hydrogen will be pumped into the core stage of the SLS, along with the upper stage. This procedure proves vital for validating multiple crucial elements of the vehicle's preparedness. Engineers will meticulously observe how the propellant tanks manage intensely cold liquids, evaluate the effectiveness and coordination of the fueling operation, and critically, inspect for any indications of leakage. Hydrogen creates a distinctive challenge. Being the smallest and lightest element known, its minuscule molecular dimensions make it particularly susceptible to escaping through microscopic openings and connections, meaning even subtle imperfections can produce leaks. Identifying and addressing these problems during ground validation is fundamentally important because propellant leaks during launch preparations could trigger substantial postponements or mission scrubbing. Should the cryogenic examination conclude successfully without major complications, NASA will advance to the wet dress rehearsal. This rehearsal represents one of the most significant steps preceding launch. During a wet dress rehearsal, the rocket receives complete fueling and the launch team executes virtually all activities that would occur on actual launch day. The countdown sequence progresses through each checkpoint, and the ground infrastructure, flight programming, and vehicle components are all tested together in an authentic simulation. The crucial distinction is that the engines remain unignited and the rocket stays grounded. Rather, the test aims to validate the complete launch procedure under genuine circumstances. For Artemis 2, the wet dress rehearsal is presently scheduled for February 2nd, merely 4 days ahead of the earliest launch opportunity. The results of this examination will decisively influence whether the mission can maintain its timeline. If procedures progress smoothly, NASA will transition directly into final launch countdown operations. However, if engineers discover any significant problems, the launch might be postponed. In certain scenarios, the vehicle may require returning to the vehicle assembly building for corrections or adjustments. This possibility cannot be overlooked, especially considering experiences from Artemis 1. During that mission's preparation phase, the liquid hydrogen leak exposed a liquid hydrogen leak that proved challenging to fix. Consequently, NASA had to transport the vehicle back to the assembly building several times for supplementary work. Combined with additional technical obstacles, these postponements extended the launch from its initial timeline in early 2022 through November 16th of that year. Fortunately, Artemis 2 possesses a reasonably wide launch window, granting NASA some scheduling flexibility. The present schedule encompasses 3 primary sets of launch possibilities. The first window includes February 6th, 7th, 8th, 10th, and 11th. The second window begins in March, with opportunities on March 6th, 7th, 8th, 9th, and 11th. A third window exists in early April, spanning April 1st, 3rd, 4th, 5th, and 6th. This indicates that February 6th represents the earliest achievable launch date, not an absolute requirement. Whether the mission will genuinely lift off on that initial date remains undetermined. From an emotional perspective, numerous people desire seeing the launch occur immediately. Nevertheless, regarding human spaceflight, success holds far greater importance than velocity. The paramount reason for this prudent methodology is that Artemis 2 carries astronauts aboard. The protection of the crew members inside Orion must perpetually remain NASA's supreme concern. Any avoidable hazards could yield serious ramifications, not solely for the astronauts themselves, but additionally for public trust in subsequent space exploration endeavors. Furthermore, Artemis 2 serves a vital function in the wider geopolitical and strategic framework of lunar exploration. It constitutes a fundamental step in America's lunar return during a period when rivalry from other countries, especially China, is escalating. Artemis 2 will become the first crewed mission venturing past low Earth orbit since the Apollo period, carrying humans closer to the Moon than they have traveled in over 5 decades. The information and insights obtained from this flight will prove indispensable for planning future crewed landings and constructing a continuous human presence on the lunar terrain. For these reasons, patience represents not merely wisdom, but necessity. While postponements can frustrate, the mission stands nearer than previously, and each successful test advances NASA one increment closer to launch. As preparations progress, updates regarding test results and schedule modifications remain essential to monitor. With that understanding, attention shifts to another significant development directly impacting the future of SLS, Orion, and the Artemis program comprehensively: NASA's budget and recent congressional actions. In the initial stages of the new presidential administration, NASA encountered a period of considerable uncertainty. The proposed budget for fiscal year 2026 included a substantial funding reduction, totaling a 24% decrease compared to fiscal year 2025. The most dramatic impact targeted NASA's science programs, which were projected to receive nearly 47% reduced funding. It bears noting that presidential budget recommendations do not automatically become legislation. Ultimate authority for federal expenditures belongs to Congress, which must deliberate, amend, and authorize appropriation measures. In this instance, both the Senate and the House of Representatives demonstrated clear opposition to the magnitude of the proposed reductions. On January 15th, following discussions and voting, the United States Senate approved a consolidated spending bill allocating $44.4 billion to NASA for fiscal year 2026. The House of Representatives had approved the identical legislation the previous week, indicating the bill will now require only the president's endorsement to become official. While the legislation directly contradicts the severe cuts proposed previously, numerous observers anticipated signing. Under the initial recommendation, NASA's budget would have decreased to $18.8 billion, with science programs experiencing the most significant reductions. Such an outcome would have profoundly weakened the agency during a critical juncture, especially as major exploration projects are scheduled for the latter part of this decade. The consolidated spending bill passed with remarkable bipartisan endorsement, demonstrating widespread concern regarding proposed funding reductions. The House approved the legislation 397 to 28, followed by an 82 to 15 vote in the Senate. The legislation combines funding for commerce, justice, science, energy and water development, and interior and environmental initiatives. For NASA, the result proves substantial. The bill essentially rejects suggested reductions to the Science Mission Directorate. While the White House requested $3.9 billion